I am standing on Greenland's ice sheet. And this is the sound of it melting.
Here's one of the innumerable so-called moulins where the water cascades into the ice sheet. And we don't know a lot about what path it takes, but it's mostly vertical.
This is Crowd Science from the BBC World Service, the show that goes to the ends of the earth to answer your science questions. I'm Marnie Chesterton. That right there was Jason Box, a climatologist. Right now, we're in one of the most remote locations this show has ever been. Ahead of the climate conference in Egypt this year, this is part of a special we're doing, inspired, of course, by your listener questions. And David, in the UK, wants to know how long before the ice caps melt. So we're here in Greenland, home to one of the world's 2 remaining ice sheets to find out. This ice sheet that I'm standing on is ground zero in the story of thawing. Greenland is melting fast, and that's largely because temperatures in the Arctic are rising much faster than the rest of the world, 4 times as fast, in fact.
Well, the amount of meltwater here has doubled in the last 50 years.
And that's what I can see in front of me. Rivers of water passing off this ice sheet and down into the sea below.
The last 2 decades, Greenland was the leading contributor to sea level rise. Prior to that were mountain glaciers, and after Greenland will be Antarctica. It's beginning to take over.
And that has consequences for people all around the world who'll never visit here. We'll come back to this spot in a bit. We started this journey as all good adventures start, getting our kit ready and provisions packed, back in the southern Greenlandic town of Narsarsuaq, population 123.
I love this little room that we're working in. It's the old hotel reception, and it's this perfectly sized room that we just taking over with all of our boxes, and it's pretty chaotic right now.
There's dozens of these metal boxes, none of which I don't think I could lift up. You're not taking all of this onto the ice, are you?
Most of this will go on ice. We have 4 days that we're planning to work and something like 10 stations to visit, so it's quite a lot going on.
Our guide for much of this episode is Jason Box, a climate scientist from the Geological Survey of Denmark and Greenland. He's in charge of this team.
This is already my 28th year traveling to Greenland, doing some of the same work, and that is installing and maintaining a network of climate recorders. If there was one thing that we had to measure, it's the melting at the surface, because of course that's the big issue with Greenland.
Why dedicate so many years of your life to researching Greenland specifically?
I sense that it's important to be part of understanding climate, because the climate warming, it really is intensifying up here. You've probably heard the Arctic is now warming 4 times faster than the globe. So very noticeable over that 28 years. The other answer is it's really exciting to look at this incredible landscape and see things with our own eyes, and that's when we really learn stuff. And you start to notice things that aren't included in the computer models, that maybe we should have a closer look at that thing.
I'm looking at the maps on the wall behind us, and I'm assuming that all of that white stuff is part of the massive Greenland ice sheet.
Yeah, and you'll notice that on a number of these maps, which are from the 1980s, these maps are really out of date because the ice is retreating out of the water, it's retreating on land.
How big is the Greenland ice sheet?
Greenland ice sheet is like 3.5 times the area of France. It's 2,300 kilometers north-south. So when you stand at the edge of the Greenland ice sheet, it's kind of an infinite view, or all the way to the horizon, but it goes far beyond the horizon. And I don't think it's possible for humans to appreciate the scale of places that are that large.
Okay, so we're in the helicopter. We're just looping up over the top of this mountain, and oh my lord, we're at the start of the ice sheet. So that the landscape's just changed amazingly, and it's gone from these dark mountains behind us, and in front of us I can just see this whiteness, this white land that stretches off into the distance, miles and miles, hundreds of miles. The surface isn't smooth. It's a really rugged looking pitted surface. And it's a beautiful sunny day out here. This is absolutely magical. Wow.
The Greenland ice sheet is massive, but it's not all the ice in the world. Not by a long shot. Most of the world's ice is round the other side of the world in Antarctica. While Greenland's ice sheet is roughly the size of Alaska, Antarctica is about 8 Alaskas. While I do a bit more staring in awe out the window, let me hand over to climate scientist Ruth Mottram from the Danish Meteorological Institute, who explains what exactly an ice sheet is and how it differs from your standard glacier. And are either of those two things an ice cap?
People used to talk about ice caps when they actually meant sea ice. So sea ice forms every year, and it's just seawater that has frozen. A glacier is land ice. It's made of compacted snow that gradually turns into ice through the decades and the millennia that it sits there. So you can think of a glacier as like a big frozen lake that starts to flow under its own weight. An ice sheet is a really, really big glacier that covers the underlying land and is dominating the topography. And an ice cap is somewhere between a glacier and ice sheets. It's bigger than a glacier. It's often on top of a mountain and it's sort of flattish on top, but it's confined by the mountain topography.
So, just like you can get your coffee in small, medium and large, you can get your giant bodies of ice as glaciers, then ice caps, then ice sheets. Earlier in the Earth's history, about 1.8 million years ago until about 11,000 years ago, ice sheets and glaciers covered most of the northern hemisphere. Today, we've got just 2 ice sheets on the chillier ends of the globe, Antarctica and up north in Greenland. That means a lot of ice has disappeared over the past 10,000 years. But what our listener David wants to know is, how long might it take for the remaining ice to turn into water? Which is what Jason and his team in Greenland are here to study.
Oh wow, I can see them! Hey, hey! I'm waving.
Yeah, there's no crevasses here, but be careful of those patches here. They go deep, but look for the dark spots.
Yeah.
You're fine.
Okay.
That was a quick safety explanation from our pilot Pilu on how to avoid wet boots or a crevasse, after which Jason took over and explained exactly where we were on this massive expanse of ice.
We're on the southern Greenland ice sheet on something we call the Q transect. At this elevation, we're about 3,000 feet thick of ice.
This is an extraordinary landscape. I don't think I've ever been anywhere like this. There are dunes made of this ice, and it's actually all sorts of colours. Bits of it are blue, there's kind of dark, mucky stuff, but there's so much of it. It stretches as far as the eye can see, and it's just incredible to think that this could all melt. Now, to be able to answer the question, when will all of this melt? We need data, and that's what Jason and his team are collecting.
My name is Jacob Jacobsen. We are measuring the snow height, how much the snow accumulates, and then it's gonna melt again. We are measuring the ice going down, and we do that using different methods.
What, like double, triple checking that they're all exactly doing it right?
Yeah. Then we are measuring temperature, humidity, and wind speed and wind direction.
What happens to all of that data?
The data is transmitted back to the office and then distributed on an open access basis.
So scientists around the world get to play with that data, put it into models?
Yes.
And then the final bit out of all of this data that you're recording is people are going to get more accurate information about this ice sheet and how it's melting.
If you go all the way down the line, is the Greenland ice sheet melting or is it not? Or is it losing mass or is it not losing mass? And it is losing.
So by adding together all the different measurements here on the ground, the results are unequivocal. Greenland is losing ice. But how long before it loses the lot? A question for Jason.
Good news is it's not going to happen immediately. It'll take a long time. There is more than 7 meters of sea level rise if all of Greenland melted. However, even a small fraction, say 10% of Greenland melt would, raise sea level 2.4 feet. That's already a problem for low-lying areas at high tide.
So a lot of climate scientists use models of how fast the Greenland ice sheet's melting.
I mean, the existing ice sheet models are still not producing the responses that we observe when we come out here and visit these places. I mean, you see the landscape changing much faster than the models are producing. So that's a good example of how useful it is to actually come and check.
So we've got two very different timescales going on here. There's the time it would take for all the ice on Greenland to melt. And as Jason says, that's a very long time, like thousands of years long. But then we've got water gushing off the ice sheet at rates exceeding climate models' predictions. And that has consequences for those of us alive today. So why aren't the models keeping up with what's actually happening? Well, the problem with models is they don't include everything, even things that are melting the ice. One factor that I'd never thought of before, but is surprisingly influential, is the colour of the ice sheet, how light or dark it is, and how that can absorb more or less sunlight. Martin Tranter from Aarhus University studies this, and I caught up with him in Reykjavik on my way to Greenland. They just happened to be having a cryosphere conference there. Cryosphere being a term for all the parts of the planet where you find frozen water. Martin has led projects called Black and Bloom and Deep Purple, and yes, those are research projects, not rock bands, where his team studies what's darkening this ice sheet and causing it to melt faster.
Over the last 20, 30 years, the Greenland ice sheet has been darkening, particularly along the western margin. The western margin where the ice sheet surface goes dark is called the dark zone. In about 2012, a bunch of us were on the ice sheet, and I was looking through at the ice sheet surface while I was having a cup of tea. And I thought, blimey, it just looks slightly mauve, slightly purple. And I thought the ice sheet surface looked alive. And I thought it was my cycling glasses. But I just said to a couple of the people that I was with, I said, I think there's a bunch of algae or microbes growing in this surface. And everybody laughed their heads off.
But Martin was right. What he was seeing was algae on the ice.
They're purple because they've got their own built-in suntan. They have a purple dye called purple agallien. And this purple agallien protects the vital organisms inside the cell from being fried by the sunlight.
What are they doing there? If I was a tiny, tiny single cellular plant, I'd want to grow somewhere warm, with a decent source of nutrients, maybe some soil, maybe somewhere in the south of France, I don't know. What are they doing up in Greenland on a glacier?
Everywhere at the Earth's surface, wherever there's water, there's life. And melting ice sheet surfaces are no different. And they're specially adapted to grow in these environments in that they're like little carbon factories. They got a lot of carbon, but they don't need much fertilizer. Just like, the plants in your garden, they're happily photosynthesizing away.
How did they get there?
The microbiologists are not 100% sure how they move from glacier to glacier to glacier. But it's almost certainly the case that it's got to be in the air. So we're testing it out, and I'm as confident as can be that we're going to find that they're in the atmosphere. Because if you think about ice algae living on an ice sheet, the ice is flowing from the centre of the ice sheet down to the margins. So the ice flow is kind of pushing you down to the edge of the ice sheet. So all the water movement is trying to flush you away. And yet the ice flow and the meltwater movement just doesn't wash the ice algae away. Somehow they get back. And the only way I can think that they can get upstream is by winds blowing them up.
And the reason why it's so important to find out why these tiny little plants are making their home on this glacier is because they're purple. They are dark.
Dark things absorb more sunlight than white things. And in Greenland in the summer, there's 24 hours of sunlight, and the UV radiation is very, very high. So they get heated by the solar radiation, and they can melt just a little bit more water to create a wet environment for them to grow in. And that's great for the ice algae, but it's not necessarily great if they're melting so much ice that it's accelerating the rate of sea level rise. And at the moment, we think they're increasing the melt rate of the Greenland ice sheet by about 1/8.
Wow.
So
they're quite a significant factor. They're doing some serious damage.
Or they're doing some serious melting, yeah. They certainly are. We think the future of the Greenland ice sheet is that it's going to darken over bigger areas. So there are going to be more melting ice surfaces in the future. And almost inevitably, they're going to be colonised by ice algae. And the question is, how many of them will grow? If it's 1 million, then it's going to be darker than the sea. If there's 1,000 or 10,000 of them per mil of ice melt, then they're still going to increase the rate of melting by about 1/8.
Is there any way of getting rid of them?
The reason I'm slightly smiling is that it's a question we get asked quite a lot. They're part of nature, they're part of life, and what right have we got to almost play God and try to get rid of them? That just doesn't sit well with me.
You're listening to Crowd Science from the BBC World Service. I'm Marnie Chesterton, and I'm sat on one of Earth's 2 remaining ice sheets in Greenland to answer David's question, how long until the ice melts? For the billions of us not living in this frozen world, what we want to know is, what are the consequences? Can we calculate how much sea levels will rise? Because, put simply, greenhouse gases heat the Earth's atmosphere, and that rising temperature melts the ice that I'm sat on, and that meltwater makes all of our coastlines creep further inland. But actually, there's a lot more that enters the equation, which is why researchers like Jason Box come to study it. Let's head back to that moulin we heard at the start, because the water barrelling down it can make its way to the bottom of the ice sheet, where it acts kind of like a lubricant, helping massive chunks of ice sheet slide from Greenland's mountainsides towards the sea.
It's really important because this water is lubricating the movement of ice for part of the year. When you consider the fact that water is heavier than ice, a full column of water can lift the entire ice sheet. And that does happen. We've measured that. You get like an uplift of like a meter when a big lake drains on the surface of the ice sheet.
Jason, is it difficult to work out how fast a lump of ice that is hundreds, thousands of miles is melting?
So I've, in my almost 3-decade career, have witnessed an explosion of knowledge and measurements and data about the place. And we We found that no matter what future trajectory there is, high or low emission scenario, Greenland will deliver at least 27 centimeters of sea level rise, and that's just up to present. That sea level commitment's only going to grow.
So that means if we all stopped putting any carbon dioxide into the atmosphere from today onwards, there's still going to be like a foot, 27 centimetres of sea level rise from this ice sheet.
That's right, and that was a conservative lower bound. When you compare CO2 and sea level, actually at this level of CO2 in the atmosphere, sea level should equilibrate at more than 10 meters higher than it is today. And there's no expected process that'll cool climate in the foreseeable future.
That is Pilu, our helicopter pilot, come to take us off this beautiful, beautiful ice sheet. It's been such a privilege to see it, and I hope it lasts longer than the science says. And I hope I have the chance to come back later in my life, and I hope when I do that this place is still here.
Now, we've heard a lot about Greenland, which is melting mighty fast. But what about Antarctica? Well, for this, I asked a researcher who studies both Greenland and Antarctica, Ruth Mottram. We heard from her earlier. She studies the world's two major ice sheets for the Danish Meteorological Institute, and I caught up with her in Reykjavik, also at that cryosphere conference.
Well, Antarctica is a much, much bigger place than Greenland. So if you melted all of the ice on Antarctica, you would get around about 60 metres of global sea level rise, compared with about bit less than 7 metres from Greenland. I think it's fair to say that most glaciologists don't believe we're going to see anything like 60 metres of sea level rise. And even if we do, it will certainly happen over thousands of years. It won't happen immediately. But we do have evidence that in the past, when it's been a little bit warmer than it is today at the moment, large amounts of sea level rise have happened, and that water has to come from somewhere. And so one of the things that is really a problem for us is trying to work out how much ice is unstable in Antarctica and how fast can that be lost.
Are there other differences between how Antarctica is losing ice versus Greenland?
About half the ice that's lost from Greenland is lost just by melting in the summer, because it gets very warm in the summer. And in Antarctica, most of the ice is lost by carving these huge icebergs. And there's also, so Antarctica is surrounded by floating ice shelves, and a lot of the ice loss there is coming from melting underneath those ice shelves. So those are very different processes. And so in Antarctica, the ocean is much more important. In Greenland, the atmosphere is really controlling what's going on.
What about all of the rest of the glaciers? The Tibetan Plateau, iconic snowy mountains all around the world. Do we need to factor them into the equation?
We definitely need to factor them into the equation. And in fact, I've got really bad news for people like myself who love visiting these areas and seeing these glaciers. They're disappearing really fast. They only have about 0.5 metre of sea level rise, though, if you average it. So they're not very big long term, but they're disappearing very fast. There's still some uncertainties, but I'm afraid it's most likely that these glaciers are going to be gone. Most of them will be gone by the end of this century.
So our listener David, say he lives a long, healthy life and makes it to 2100. Do we know how high the sea levels will rise by then?
Well, we have a range of estimates. I think the biggest uncertainty is really burning of fossil fuels and carbon dioxide emissions. So the faster you can reduce your use of fossil fuels and all the other things that contribute to climate change, then the lower the sea is going to rise. And so we have a range of estimates, and that's around about 1 metre in some high-end scenarios. It might be as little as 0.5 metre in some of the lower-end scenarios, but there is going to be some sea level rise by the end of this century. But as I say, it's going to take centuries for sea level rise to stop. Previously, we've always stopped at 2100, but that's very misleading. Out to 2300, 2500, we expect to still see the seas rising.
So probably 1 metre in our lifetime.
Well, by the end of this century, one of the things we've been talking about is really about ice shelves around Antarctica. We know the ocean is getting warmer. The heat in the atmosphere is 95% of it is going into the ocean. So the ocean is warming up, and that's having an effect on these ice shelves, and it's undermining them from below.
Is the ocean getting warmer having an effect on sea level?
That has a big effect on sea level. The ocean getting warmer, actually, until quite recently, the expansion of the ocean, as the water gets warmer, it expands, and that was actually our primary contributor to sea level rise so far. That process will also continue over many centuries because it takes a long time for the heat in the atmosphere to work its way down into the deep parts of the ocean, which are cooler.
So warmer water takes up more room?
Warmer water takes up more room, yeah. This is a very simple experiment you can do in your own home. Make a cup of tea and measure the same amount of cold water and then heat it up and see how much taller it is.
So Greenland is contributing every third teaspoon of water to sea level rise. That's what I've read.
That's about right. There are some sort of useful rules of thumb. So 1 gigaton, which is a cube of water 1 kilometre by 1 kilometre by 1 kilometre, that's 1 billion litres of water. Greenland loses around about 250 to 280 gigatons every single year on average, and Antarctica loses around about 110 gigatons of ice per year every year. So every year Greenland loses around about 0.7 millimetres of global sea level rise.
All right, well, David, it'll take all of the ice trapped in the Antarctic and Greenland ice sheets millennia to melt. However, the melt we're seeing now, which is accelerating thanks to our fondness for fossil fuels, means sea levels will rise significantly this century and in the centuries to come. The process of studying these ice sheets involves long days of physical labour, setting up rigs, fixing weather stations, shunting boxes of heavy kit in and out of a helicopter. One reward for these scientists comes at the end of the day when, dog-tired, they can grab a drink, stare up at the northern lights dancing in the sky, and reflect on the bigger picture behind all this work.
There went a shooting star.
I just want to say the smear of northern lights in front of us has just been fantastic.
Here we are in Greenland looking at these northern lights. This place is so reliable for that.
We've got our drinks, no ice, but I think you've had enough ice today, right?
Yeah, we were working ourselves quite hard on day 3 of our ice recorder measurement maintenance. We were lucky with the weather, but we were hustling, sweating, rebuilding some equipment that got crushed by settling snow.
I've got to ask, so people talk about there being years of more ice and there being years of less ice. What if this is just like a big long run of less ice and things are going to turn around? Maybe?
I wish there was a scientific prospect for the melt to pause, but as humans add more than 40 billion tons of carbon each year to the atmosphere, it just adds more blankets on, and it has a heating effect.
But it's definitely going. The ice sheet that we've been on is going.
Yeah, Greenland has entered an exponential loss. Now we're rocketing into a more hyperactive whole climate system, really. And the fact is that the climate system is more sensitive than we can appreciate, but there are layers of interacting effects that produce a more sensitive response, especially for ice. Ice is one of the more sensitive indicators, if not the most sensitive. So my job's pretty easy to tease out the story that ice tells.
So, the reason I'm here bothering you is because one of our listeners wanted to know when the ice sheets are going to melt, when's all the ice going? And it sounds like it's not going to happen in our lifetime.
Not all. No. Even small fractions of this large mass will matter. They do matter. say if 10% of Greenland ice is lost, that's 70 centimeters. We estimate that by end of century, the sea level rise commitment from Greenland stands above a meter, about 3 feet. It's not like the climate's going to stop warming in the year 2100, actually. Sea level rise will probably continue accelerating for at least a few centuries. And of course, it's kind of impossible to predict what the world will be like in 200 years. But those are the years when we'll be talking about meters of sea level rise.
I mean, we've got our drinks. Is there anything positive that we can cheer to? Can we clink to anything?
I think the efforts to reduce carbon emissions and to start getting into carbon removal from the atmosphere, while expensive, have the great benefit of beginning to put the brakes on, slow this thing down, and that'll buy time, and in effect it'll save lives. And I think we all want to sustain the natural world, which has been hammered by human activity. We owe it to nature to be smarter.
To putting the brakes on.
Cheers.
It feels odd to have seen this ice sheet, knowing that the frozen water here is travelling to very different places and is already affecting so many of our lives. Which brings us to another listener question.
I'm Johan, calling from Slagelse in Denmark. Melting poles and high seas seem to be unavoidable, so maybe we should start looking for another place to live. So my question is, where do we go to live when the poles have melted away?
That's a great question, but unfortunately it's one our listeners will have to wait until next week to hear the answer to. Special thanks this week to Jason and his crew, and to listener David for his question. If you have a question for Crowdscience, get in touch with us at crowdscience@bbc.co.uk. This episode was produced by Sam Baker and presented by me, Marnie Chesterton. Thanks for listening.